In this lecture, we'll start looking into the code for our machine learning API. To begin with, let's review the requirements and config. So we're here in the section 6 directory, house prices API subdirectory, and we've got a test requirements txt. Now this is the same as in section 5 with the addition of the requests HTTP client. This is required by the FastAPI test client. So not much to note here. And then in the main requirements file, the chief thing to take note of is here on line 8, where we've taken a little bit of a shortcut here to aid with learning. We've published the machine learning package that we created in the previous section under this name, Training Data Regression Model. And this has gone to the default Python index server, PyPI. This version is synced to the code as it was in section 5, so everything that we import from this package should be familiar. There are a few other additions in here which we're going to get to, but obviously we have FastAPI and Pydantic, you'll recall, we used in the previous section as well, and we'll discuss some of these other requirements as we look at them in the code. Next up, within our app subdirectory we have these 3 key files. Let's start by looking at the config, and you'll notice that here again we're making use of Pydantic and the base settings to create our config class. So we have some config for logging, which we're going to come to in a dedicated lecture, and we also have this settings class where we specify things like our project name. This class config is specific to Pydantic, and it just means that we can specify some options for our Pydantic classes, like they are case sensitive. I'm going to keep scrolling down, and we'll talk more about the logging and the setup in the dedicated logging lecture, but you'll notice that this settings object is exported, and this is what we'll be working with throughout our code. Then if we look at the main module, in here we bring our config in and some of the imports from FastAPI, chiefly this FastAPI class, which is how we define the main app that we're going to be working with. And the app uses a few different routers. So we have what we're calling a root router, and this is the way that we define endpoints in FastAPI. So we use this decorator syntax with our router defining the URL of the endpoint. In this case it's just the /, and then we define a function which specifies, as you recall from the FastAPI introduction, an input request, and this request object we import from FastAPI. It gives us a few helper methods, and this is a very simple endpoint where we're defining a body and returning it as HTML, and this HTML response again is from FastAPI. And what this gives us is our home endpoint, where we see the welcome to the API view. You'll notice as well that we're importing another router from the API module. This is where we specify the more complex API endpoints. And the key thing to note is that we have to specify each of these using the app include router method. And so we've got the routes and the API router both included in our app. So again, here we define the API router, which we imported in that main module. And it's the same syntax here with the decorator, and we have our health endpoint, which we saw in the opening lecture, and also our predict endpoint. Now, in the case of the health endpoint, we define a response schema, which we'll be looking at in the next lecture, and we return that as a dictionary, and under the hood FastAPI will do the conversion to JSON for a JSON response here. And we have some FastAPI helper arguments, like we're specifying that the status code for this endpoint by default is going to be 200. Let's now look at our predict endpoint, which is more complex. So I'm going to create a little more space here. Let me walk you through this. So the expected inputs make use of a schema, and that's what we'll be looking at in the next lecture. But we go through this progression here where we load the inputs into a pandas data frame, and we use this FastAPI JSONable encoder. You can see that we import this up here. And this handles loading the Pydantic data into JSON in the format that's expected by Pandas. We have some logging, and then we're calling make prediction. Now this should be familiar because this is the exact same make prediction function which we defined in our package. And this is imported from the package. So just to reiterate, we've set in our requirements file the train in data regression model package. This is now available in our API module, and we can import anything from that package, including our regression model predict make prediction. And just to refresh your memory, if we go back to section 5 and into our regression model, you'll recall that we have predict and make prediction. So it's this exact function. And we get the results from the function. You'll recall that make prediction returns this dictionary. Let's have a look again. The dictionary looks like this with our predictions, our version, and any errors. And so we do a check here. If there are errors, then we're going to raise an HTTP exception, and the client will receive a 400 code as well as details of the error. If there are no errors, then we return the results, and these are going to be in the format specified in our response model. And this is some of the beauty of Pydantic and FastAPI working together to make all our inputs and outputs very clear. Other things to note here are that we need to replace the NumPy NANs with none so that Pydantic can work with them correctly. And later on in the section, I'll explain more about when we would use async and the implications for the performance of our API. Okay, I want to bring everything together now by looking at the tests we have for this predict endpoint. So if we go into app tests, we have the test API module. And as with the previous section, we've just provided here an example test. In reality, you would make many more tests, but this is a useful starting point to explain some of the key setup and principles. We also have a dedicated course specifically on testing. You'll see here that our test has these two fixtures, which we have defined in our conf test module. The two fixtures are the client, and this is a standard pattern for setting up a FastAPI test client so that we can make API calls. And test data, and crucially here, you'll note that we use the load dataset function from our package, as well as the test data file from our package. So the way that we've packaged things up here means that any consuming application of the package gets out of the box a series of test data and utilities to make use of that test data. So this is great, means that we don't end up writing the same code or losing track of our test data. And then our setup here is that we prepare a payload, so this is going to be the body of our post request to the endpoint. Using our test client, we make a post, passing in the payload as the JSON body of the request, and you'll notice that we're posting to the predict endpoint. And then we expect that in the response we get a 200, and within the prediction data that's in the response body, we're going to find predictions. And there are many predictions, right, because we have multiple rows in this input data, but the very first prediction we expect to be 113,422 within a relative tolerance of 100. So let's give this a try and run it. So you need to make sure that you're in section 6 and house prices API. We're going to run tox-e test app. So I've run this command before, so all the dependencies and virtual environment are already installed. The first time you run it, it will need to prepare those. But here we go, our test app commands have succeeded. So run this on your local machine, check that it's working, and then you can experiment, right? If this predict was not the right endpoint, and I were to rerun the command, we'd expect a failure here. Yeah, you can see we're getting a 404 back from our API server. So this gives you a feel for some of the key bits of functionality of our API, how the modules are structured and work together, and how we're making use of this machine learning model dependency package. Okay, in the next lecture we'll dig further into the schemas.